We quickly approaching the end of the day, and before the last talk, I want to make some reminders for you. We'll have a party tonight starting at 10 p.m. at Apollo 111. I hope to see you all there. After a long day like this, definitely a party will be really good. You probably also received the link for a form. Please do share your feedback about the speakers, about the presentation, topics that you would like to see next time here, and also what you enjoyed more at Dev Talks. And third, and not least, after this last talk, please go to the main stage to see if you are one of the winners of the partners prizes that occur during the day in different places of the area. And not to lose more time, as we spoke during the day about mobile and also web, we kind of discussed how hard it is to implement something that works on all platforms. And we have Frank here to tell us how easy it will be if you're using Xamarin. Welcome, Frank.
Hi, nice to be here. I want to speak to everybody who's now leaving. Please join my session. I know it's late. I'm very happy that you guys are here. I'm going to do some talking about cross-platform development with Xamarin Forms. Oh, wait. There we go. Startup issues. There we go, that's better. Those are my slides. I'm going to go through it relatively quickly. I hope to do a few demos as well, to have some time for it. A little bit about myself. Frank Folsche. I work in the Netherlands, same company as Chris that you might have seen earlier. Mainly .NET development, but also a lot of front-end development that I'm working on. Please contact me if you have any questions. All right, so how's this presentation set up? We started with a small introduction about the company, about the app that we build. Then we go off to Xamarin, then what Xamarin Forms adds. A little bit of unit testing. I think every programming slide has something about unit testing. We will dig into release management a little bit. Analytics, how we implemented it, and to illustrate an example of something we implemented. Hopefully we have time for a small demo. All right, first, the company and the app. I'm not going to bore you too much with it. It's a wholesale company who has an app for their customers. They sell water heater products. So not a very interesting domain maybe, but hopefully the technology behind it is interesting. All right, so for the app, when I started on the project, there were already 3 different apps developed, an Android app, iOS, and Windows app. The main key features are still the same in the new application. That's for a water heater maintenance. So a water heater, they come to your house, check out your water heater, and they want to know what water heater you have, what parts are in there, be able to order them. Also see some fault information about it. So that's interesting. The app was already for 3 platforms. So that was also a requirement when building the new application. Moving on to the technology behind the app. We did have a look at different options of creating mobile applications. Obviously, there's the native solution, building a app completely from scratch for every platform. So Swift for iOS, Java, or Kotlin I've heard for Android, and C# for Windows, obviously. Probably, if you have a lot of time to spend, this is the best way and the way with the biggest community to create mobile applications. Then we have a very popular alternative, is building applications with web-based technologies. There is a place for this, but if you want to build real great native applications, they won't be as good as our native solutions. I did do a lot of JavaScript development, also with TypeScript and Angular, so I had a lot of, I was very familiar with these technologies. So for me, it was an option to look at. The other one I've looked at is Xamarin. So basically, we will go into this a bit more detail, but you build applications with C# across all 3 platforms. And then we have Xamarin Forms, and what it basically adds to the mix is that you also can write your user interface in a shared language using Microsoft's preferred user interface language, XAML. All right, so let's have a look at Xamarin. How does it work? What can you do with it? Like I said, you build apps using C#. So all your shared logic can be written in C#. But very important to understand that using Xamarin, you still build your user interface in the platform-specific technologies. So for iOS, you probably want to use storyboards or write it with code behind. For Android, you want to use the XML user interface technology. And for Windows, probably XAML. How does this work? You write your C# code, and it depends on the platform how it's going to run. So on iOS, it will be compiled down to machine code, and this is the main reason behind this is because Apple doesn't allow runtimes on iOS. Android does, so when running your Xamarin application in Android, it will run in the mono runtime on Android. And obviously for Windows, it's just a C# project. You can share your code and run it in the native runtime. All right, cool. So we're going to develop C# applications on all platforms. So how does your programming environment look like if you're doing this? You can choose Windows, develop on Windows or a Mac. I choose to use Windows, and the main reason was when you want to use Windows development, you need a Windows machine. So for me, the only viable option really was to use Windows. But a lot of you out there probably only want to make Android and iOS applications. Then you can just as well build your applications using a Mac. On the machine, you want to run Visual Studio. I think a month ago, Visual Studio for Mac also released, so you can use Visual Studio on Mac as well. And then you have 3 projects running there. Within Visual Studio, now it comes up solutions. A solution is just a way to bundle projects. And here we can see we have a shared project and a project for every platform. So we have an Android project, an iOS project, and a Windows project. These projects are used to write your platform-specific code. When you use Xamarin, you write your user interface language there, maybe some specific logic to access your flashlight, stuff like that. And your shared code, you want to put as much as possible code there. So your business logic, your communication with your backend can all be added there. OK, but wait, we talked about that you need a Windows machine to develop for Windows. How does that work for iOS? Yes, you do need a Mac to develop on iOS. Xamarin solved this by connecting through SSH to a Mac, which runs Xcode. So basically what will happen, when you run the Start button in Visual Studio on your Windows machine, what it actually does is it will go out to the Mac, build your code there, and start up the emulator on the Mac there and runs your code. So actually, yes, you do need a Mac. There are some alternatives now. I think the Xamarin Previewer just released. It's still in preview, which you can actually push code to an iOS device without using a Mac. But the preferred way, and probably you will end up still using a Mac. All right, I want to demo this a little bit. I didn't bring my Mac building machine, actually running a Mac, but it runs on Windows. So here we have our the project of the application that we build. I currently have selected the Android application as my starter project, and actually already running. So what I can do now, what you see is that I have a breakpoint set in my code behind. For now, just some C# code. So when we move over to my mobile phone, now you all know my password. That's very smart. I'm going to change that. We can see the app is running on my Android device. It's actually the device here that's mirroring on my desktop. And when we now press a button, so it's actually pressing the button on the device, but I can debug it using Visual Studio, and I can see the C# code. So when we look a little bit into that, you have all the things that you expect from debugging experience. So I can look into objects. I can see what properties are on there. So I can see it have a settings property with all kinds of data. And I can just step through it like you would normally do. And if I put those together, when I run, run through it, you can see the application on my mobile phone just continues like you would. So you have a very rich debugging experience. And this works exactly the same on the Mac. So the app will start up on the Mac, and you can just debug like you normally would with a C# application. Let's see where we left off. All right, so a small introduction into Xamarin, how you build cross-platform applications using Xamarin. All right, this session is about Xamarin Forms. So what does Xamarin Forms bring to the mix? Here we have the differences between Xamarin and Xamarin Forms. So what Xamarin Forms adds is a shared UI logic. So you can actually build your user interface using a shared language. There is still the opportunity to write some code specific to a platform. So, for example, like the thing I mentioned earlier, you want to reach out to your flashlight on a function that's specifically for iOS. You can still write the code specifically for the iOS platform. What's very important here, that code is written in C#. It's just not shared across the platforms. All right. When you want to do Xamarin Forms development, you want to use the MVVM pattern. This is a pattern by Microsoft that's widely used in WPF applications. I'm not going to go into it in much detail, but basically it consists of 3 parts. Your model, which basically holds your data and maybe some business logic, whether a field needs to be filled in or not. Your view model, which has all your presentation logic, whether a button is visible, what will happen when you click on the button, your page navigation, all this logic will be defined in your view model. And then you have the view, which should only have view logic. Where is the button placed, and not what happens when I click on that button. So how this looks like? Well, this is a simple model. I didn't have any business rules to it. Then we have our view model. This is a slightly simplified version of what we can see in the application. Here we have a list of brands in our case. We have a title, which just returns a string. And we have a command, which is going to be triggered when we click on the button. When we look at the view, a simplified version of the view that belongs to this, we can see how the view model is interacting with the view. So here we can see the page title, which data binds to the title property of the page. We have a list view object, which binds to the list of brands we have in our view model. And we specify what happens when we click on one item in that list. So here you can see how the MVVM pattern works within Xamarin Forms to create the user interface and interact with it. What's quite unique about Xamarin Forms when you compare it to other cross-platform languages, like for example your JavaScript and HTML way of doing Cordova development, is that the UI can adapt to the platform you're running on. So in this case, in XAML, we specify a tabbed page. So a tabbed page is a construct that Xamarin Forms created, and that will look differently on every application or every platform. So when we look at the Windows example, we can see we have 2 tabs here, articles and error codes. And those are displayed in a way that a Windows user would probably expect the tabs to be displayed. Same for Android, tabs are above a list. But for iOS, very interestingly, the tabs are always at the bottom of a list. So you can see that the XAML, the Xamarin Forms UI logic, is compiled down to the platform-specific UI. And obviously you can all override this, but this is the default behavior. Okay, so what happens if you want to do some platform-specific logic and want to execute it from your shared code base? Xamarin works with specifying an interface. So you have some action you want to do, so you wrap this in the interface. In this case, I'm going to run through an example of Google Analytics. So what we have is an interface with one method that tracks a page. So when a user gets on a page, analytics event will be sent. So from our shared code, we can call this on one place. And what happens here is that we get a specific implementation of that interface. So for iOS, we get a different implementation than for Android. This is how one of those implementations will look like. So here we specify using assembly reference that we're going to use this to be dependency injected. And then we just implement a method. So we have 3 implementations in this case, because we use 3 slightly different libraries to do analytics. For Android, there's a different library. For iOS, there's a different library. And for Windows, there's a different library. So this way you can implement platform-specific code, but still call it in the same way. Because when we look at our shared code, we can just call the track app pages from this object, and it will be executed in the way we want on a specific platform. I think I'm going to skip unit testing. We're running out of time a little bit. Let's hit it briefly. The main thing is that it's nothing different from normal .NET unit testing. So you can use all the libraries, all the features that are already in the .NET framework. So you have a very rich unit test experience out of the box. It works exactly the same as it would in a normal .NET environment. And obviously, those tests run for all applications. You only have to write your test once, and you can cover the shared logic of Windows, iOS, in our case, or Windows, iOS, and Android applications. Release management. OK, so we wrote an application using Xamarin. We have some UI. We neatly wrote our unit tests. How are you going to release this? It's slightly different, but quite similar for each platform. I think Android is now currently, the implementation is the nicest. So what we can do is we can create packages. So now you can see I have a couple of release versions. So already up to version 66 of our application. And what we can do is just click on the distribute button. So this is still all from inside Visual Studio. When releasing for Android, we can choose whether we want an ad hoc deployment, which just outputs the APK file, the build file to our system, or publish it directly to the Google Play Store. I prefer to choose the Google Play Store version. Of course, we have to sign it with something, so we choose our certificate. And then, very interestingly, we can hook up to the APIs that Google has to be able to publish our application. So here we choose the Google Play Store account that we wanted to publish our application to. And now we can actually choose to publish the application to a specified track on Google Play. So for our application, we let our internal testers use the alpha track to test the application, and then we move it to the beta track, and then to production. So I just have to click upload here, and the application will upload to the Play Store, and the tester can access it on his phone. For iOS, it's very similar. You can do most of the steps on Windows, but in the end, for iOS, it's just because Apple wants it like that. You still need to go on your Mac and upload from your Mac the package file to Apple. So what I usually choose to do is just open my Mac, Visual Studio on the Mac, and go through a similar process. So I've created a deployment file here. I can click Sign and Distribute. Here again, go through a similar process. And now when you choose App Store, you hope you can publish it directly to the App Store. It's not exactly like that. So we choose a provisioning profile, certificates, etc. And we say Publish. And it only outputs the file, and you can open the Apple application loader to actually upload the file. So a little bit more manual work here. But still a quite nice process. I won't go into Windows a little bit, not that much. It's basically the standard Windows application publishing system. There's nothing specific to Xamarin about this. All right, we saw a little implementation of Google Analytics on different platforms. So what I want to ask you is to scan this QR code or search on ServiceWiser. You can actually download the app. So this talk is also called real life application development. So this app is actually now in production for about 2 months. So when you search for this, you can actually open the application, and we'll later see what that brings us. Why I choose to talk about analytics is because it's a great way to illustrate what's possible with this technology. There are 3 different Xamarin libraries to do analytics, because they ported from the native functionality, so they're slightly different. So we've made a common interface to track this. And what you get with this, because every page exists on all platforms, and they all have the same properties, all have the same text, all display the same data. They're very similar. So you can very well track the use of the application across the different platforms. A few statistics that we got out of the app. I'm not going to explain them. That's for our data analysts to do, but it's interesting to see. We have a little bit more Android users than iOS users on our application. This little thing here is our Windows user base. So yeah, we might have to revise why we actually build a Windows application, but it's interesting to see. Another interesting thing is that an iOS user visits more screens on the app than an Android user does. Why, I'm not sure. Maybe it works smoother, so they click through the app faster, or they just need more actions to get to where they want to go. At least it's interesting. Another interesting thing is that when we look at the sales through our application, we can see we have about 17 orders per 1,000 sessions on Android devices. But you can see this number is significantly higher on iOS devices. So apparently on our application, iOS users are more likely to buy stuff through the app. Whether that is because there's a huge customer who rolls out iOS devices and let them order it, we're actually not that sure. But again, it's a great way to do the analysis across all platforms and be sure that the analysis is exactly the same. There's no mistakes made in how this information is sent, because we treat all the platforms the same way. So I hope you all scanned the code and how if the app open. One interesting thing is that what we can do is you can actually see the real-time usage of the app right now. So once you guys start opening the app, we should see this number increasing. As it's an app used during work hours, you won't see much usage now. Actually, you can see real-time usage, and this is usage from iOS, Android, or Windows devices. It doesn't really matter. And I was actually hoping, not yet, that our top applications would go to the Ukraine a bit more. I'm already warned our Google Analytics person that you shouldn't be too worried about people downloading the app from the Ukraine. All right, back to the slides. I have 4 minutes left. I think we can squeeze in a little demo to see how easy it is to develop new features using Xamarin Forms. So what I have here is the latest development version of our application on the development branch. So let's say we have a use case that we want to add a battery indicator to our application. One of the cool things that we can do is use the built-in package manager. Let's stop this. So this is just the default, click the wrong button there. Default package manager that you will use for any .NET application. So we can search for a plugin that will help us doing battery. So let's search for battery. We have a Xamarin Forms battery here, and we have to install this battery plugin on all platforms, including the shared library. So what it will do is it will install a specific implementation for each platform and a shared functionality to call upon that logic. So let's install this. So I hope the internet works with me. Always dangerous to do a demo with internet. All right. We actually use a local repository at the office that's only available internally. So I have to turn that off. Okay, fingers crossed. There it goes. So, well, it also illustrates that you can have your own repository in your office, sharing your own Xamarin libraries that you might want to share across projects. Maybe some shared business logic that you can import in your application. All right, so the package installed in all projects. So now we go to our application, and obviously showing the battery status is something you want to expose from the view model. So let's go to our settings page, for example. And what we'll do here is we make a new public property. Let's make it of type string, and we call it battery. And we only want to get the battery status. So we want to return something. By default, this API exposes a static method which we can call upon. Obviously, you can change that. Got it right here. Cross battery, that's the one. So what we do is we use the plugin we just downloaded, which has a method remaining battery percentages. And obviously we want to return a string, and this is a number. So let's add a percentage mark to that. So basically, even this small thing, you preferably want to do that in your code behind, because it's shared logic among your application. I'm going to demo this using the Windows application. I often use the Windows application to initially do my development, because it just runs the fastest on my device. Obviously, I have a Windows machine, so I can very quickly start the application up. And a lot of times that's just enough, and I just check on Android or iOS if it actually works as I would expect. All right, so deploy to my machine. It starts up. The green color is because of my Windows theme. Looks a bit ugly, actually, but I might need to change that. So there we have it, a very similar app to the one you saw on my Android device. So now we go to the settings screen. I made a mistake because I didn't add it to the view yet. Sorry about that. So we added the logic, so now we need to expose it to the view. It's actually very simple. Maybe that's why I forgot about it. Let's go to the bottom here. This looks like a nice page where we can just add a label. And then we want to display some text in the label, which is our battery. So now I bind to a property on my view model. And actually should be as easy as this. So basically this specifies that I want to bind to the view model associated with this view, and this is the property I want to expose. Let's see if it actually shows up now. There we go, it deploys a bit faster, luckily. So now we go to the settings page. We can actually see the battery percentage down here. And this will show up on iOS and Android as well as it does here. So very easy way to use libraries that are built by the community, add them to your project, and share that functionality across all platforms. And yeah, it runs as a native application. Let's go back to the slides. All right, so let's conclude what we just have seen. I think there's a very interesting dynamic between Xamarin and Xamarin Forms. When should you use which application? I think it's a bit similar to a discussion which you would have, and when would you use Cordova over native. Xamarin Forms does help you to quickly develop applications. You can specify UI logic once, and then it runs on all platforms. But what you often see, especially with bigger applications, that you do want to specify your logic more detailed. For example, you have a designer on the team who's very picky about how this drop-down works or how this scrolling list works. And Xamarin would give you a lot of much more freedom. With Xamarin Forms, you can do exactly everything you can do with Xamarin. But it's a waste to define a button once and then still have to override it on each platform. So if you have very strict design requirements, you might want to consider Xamarin over Xamarin Forms. When you have a bit more relaxed, maybe a line of business application with just some forms, I think Xamarin Forms is a very good choice. Any disadvantages? I kind of had to talk about this. I did a session earlier, and then they said, oh, you have to talk about disadvantages. There are a few minor ones. Originally, Xamarin was paid, so now it's basically for free. So that was one of the biggest drawbacks that's basically now eliminated. One of the disadvantages I can think about is that it does increase your package size slightly. So if you're very picky about how big is my application once I deploy it, it might increase a little bit. I had one more disadvantage. I think that's about it. For me, it worked very well. You will run into quirks. But I think you will run into just as much quirks if you have to develop 3 applications separately on each platform, have to deploy it there, have to deploy it here. You will run into things. The one main big advantage why I would use Xamarin is maintainability. We currently work on one app with one project team, which all can ship out new features on all 3 platforms. They don't need to know every little detail about specific implementations on iOS or Android. And obviously unit tests, you can share them from the view model point of view. You can write your unit tests for all 3 platforms. And what you saw today is the conclusion of about a 1-year project, which also includes a lot of back-end work and other stuff. I think it reaches more than 80% code sharing, and we have 3 apps currently in production. So I want to leave it with that. Yeah, thank you for your time.
Are there any questions directly? No? Wanted to make sure.
No, no questions?
Yeah, thank you so much, Frank.
I think everybody wants to go to the after party. Thank you.
Yeah, and as Frank, see you around 10 p.m. at Apollo 1.